Alright, so Unit 3, Notes 2, Part 2, we're actually going to begin this video with a review from what we learned in Part 1 of the video, and we're actually going to practice that with practice problem number 5. So go ahead and try to pause the video and attempt practice problems 5 and 6. We will go over both problems here beginning now. Okay, so in practice problem 5, we want to name the following compounds. What we want to do here is name each of these compounds using the traditional rules for covalent compounds, using the prefix chart as well. Remember that this is only used in covalent compounds. It is not used for ionic compounds. Okay, so beginning with CO. We know that C is carbon, and we know that O is oxygen. Okay, but remember we have to change the ending of the second element or the last element to oxide. We have to replace the ending with "ide." And that's true not only for covalent compounds, but also ionic compounds. But the difference for covalent compounds is that we have to also add the prefix for the elements. So since we only have one oxygen, we're going to add monoxide as the prefix, where mono is the prefix there. We don't put monoxide because then it just kind of looks like a monoxide. So that's kind of weird. So we are going to actually delete an O, kind of combine this O with the oxygen and the mono. So monoxide is the name for this one. The second one is carbon. It's very similar. It's carbon as the first one. And then oxygen again as the second element. But again, we're going to change it to oxide. But instead of oxide, we need to include that prefix. So since we have a 2 there, we're going to call it carbon dioxide. Right, the next one here is going to be nitrogen and then monoxide. So pretty straightforward here. So we have just an N for nitrogen, O for oxygen, but we only have one, so it's monoxide. And then very similar to what we were just doing with the carbon, it's nitrogen dioxide. Very similar to what we just saw with the carbon. All right, so let's take a look at the ones on the right here. We have sulfur. That's going to be the first element. And then we have fluorine, but we're not going to call it fluorine. We're actually going to call it fluoride. But we also need to increase or include the amount that we have here. So we have a hexa as our prefix because we have 6 of these. So sulfur hexafluoride. Oh, don't know what happened there. Is what we have for this formula. The next one we have silicon as our first element, so silicon. And then we want to start getting into the habit of including the prefixes before we type out the element. So the 4 for the fluorine is going to be tetra. And instead of fluorine, we have fluoride. So silicon tetrafluoride. Right, so this is the first one. This next one is going to be the first one where we actually see a number with the first element. So we actually do need to include the prefix there. So we have the number 2. So that's going to be di-nitrogen. And then the next element is going to have a 3. So that's tri, and then sulfur. Right, but we're not going to say sulfur. We're going to call it sulfide because, again, we have to change that ending. SO2 is going to be sulfur dioxide. All right, so that's practice problem number 5. Let's go ahead and work on practice problem number 6. So here we're doing the exact opposite, again doing a review of what we learned in the previous notes, taking the chemical name and trying to come up with a formula. So boron is abbreviated with the letter B, and chloride comes from chlorine, so we're going to put Cl. And the tri indicates that there's 3 of them, so it's BCl3. Nitrogen monoxide, so N is for nitrogen, and then we don't have any prefixes here, so we're just going to leave it as 1. And then monoxide means that we have an O, and there's only one of them, but we don't have to put the number 1. Dinitrogen pentoxide, so di means 2, and then we have 2 nitrogens. Pentoxide, oxygen means that we have oxygen right here, and then there's 5 of them. Pentoxide. All right, carbon disulfide. So carbon, no prefix, so we're only going to have that one carbon. Disulfide. Sulfide indicates sulfur, and di means that we have 2 of them. oxygen difluoride. So oxygen is going to be just one like there. There's no prefix, so we just have that one oxygen. Difluoride. So we have a fluoride, and then di means two. And then xenon tetrafluoride. Xenon, no prefix, so we just have one of them, Xe. And then tetrafluoride. Fluoride comes from fluorine. Tetra means that we have four of them. All right, so there we have it, just a quick review of what we learned in the first section of Unit 3, Notes 2. All right, so in the first part of Unit 3, Notes 2, we learned about covalent compounds, how they're formed, and what they basically look like, and also how to name them, right? So in this section of notes, what we're going to take a look at is very specific covalent compounds called organic compounds. All right, so what are organic compounds? Well, organic compounds are going to be compounds that are covalently bonded and have a chain of carbon atoms. So in organic chemistry, what determines whether something is organic or not is whether or not it has the element carbon in it. And so organic chemistry is basically focused around the element carbon and things bonded to it. Over here we have a list of things called hydrocarbons, which are examples of organic compounds. And hydrocarbons typically only have two elements in them. One of them is going to be carbon, like I mentioned before. The other one, you could probably guess just based off of the name, hydrocarbon, right? So the second one is hydrogen. Hydrogen and carbon are the only two molecules present in all of these atoms. And so you can see here, if a molecule has 1 to 4 number of atoms, the state of matter that it's going to be gas. If we start to add more atoms, more carbons, and more hydrogens, what we'll notice is that the state of matter actually starts to become more dense, and then we start to see liquids. And then finally, if the number of atoms is really high, like 50 or above, we start to see that the state of matter becomes solid. It's going to be even more dense. All right, so these hydrocarbons, they are made up of only carbon and hydrogen, and the state of matter becomes more dense depending on how many atoms you have. So what's the significance of these hydrocarbons? What are they used for? Well, here are some great examples. We have heating fuel, cooking fuel, gasoline, jet fuel, portable stove fuel, diesel, lubricants, heating oil, and then finally petroleum jelly and paraffin wax as solids. So one thing that all of these things have in common is that they're really good at producing heat when burnt. So they burn very easily and they produce heat when we burn them. So a lot of these things we do burn in order to produce heat or transfer that energy into some other form of energy. All right, so these hydrocarbons, once again, just to reiterate, three things. The first thing, they are only made up of two elements, hydrogen and carbon. The second thing is that the number of atoms that they have, the more atoms they have, the more dense the state of matter. And then the third thing that we talked about is the hydrocarbon use is mostly going to be for burning and producing heat. In this slide, we can actually see a few examples of hydrocarbons. So here are just some that have specific names like ethane, propane, butane, and pentane. The first thing you probably notice is that they all end in ane, so A-N-E. Another thing that you might have noticed is that they are literally straight chains of carbons, like we've mentioned before. So these are organic compounds, and they are a hydrocarbon, which is a type of organic compound, because they only contain hydrogen and carbon, like we mentioned in the previous slide. So the number of carbons really tells us what kind of name this organic compound is going to have. So we're only taking a look at these hydrocarbons for now. And the number of carbons, again, will give us the root word for these organic compounds. So if we take a look at the previous slide, we see ethane, propane, butane, and pentane. I'm going to go back and forth between this slide and the slide we were just on. So if the number of carbons is 1, then the root word is going to be meth, like methane or natural gas. If the number of carbons is 2, then we have ethane. If the number of carbons is 3, then the root word is going to be prop. Okay, so over here you can see eth for ethane because it has 2 carbons. 3 carbons gives us prop, right? Because we said prop was 3. 4 carbons is going to be bute, so that's going to be like butane. Pentane is going to be 5 carbons, so the root word was 5. And then hex is going to be the root word for 6 carbons, but we don't have an example of hexane. But basically what we would do is just add another carbon surrounded by hydrogens. Okay, so the structures for this, if there are only single bonds for these hydrocarbons, they are known to be what's called saturated hydrocarbons. What does the word saturated mean? It basically means that we can't include any more hydrogens if we wanted to. So like if you were to take a sponge and put it in water, you would completely saturate the sponge, meaning the sponge would not be able to hold any more water. Similarly, this carbon atom right here cannot hold any more hydrogens because it has already filled up all of its valence electron slots. So it has a total of 8 valence electrons being shared with all of these hydrogens. So if you only see single bonds, that's saturated. Okay, so associate that both of these words begin with S, single and saturated, single and saturated. Okay, they are named for how many carbon atoms there are. So if there are only single bonds, they are always going to end in ane. So like for instance, meth for 1 carbon. So if we go back to our chart, meth is for 1 carbon, and then only single bonds, the ending is going to be ane. Okay, here's some more examples. Ethane has 2 carbons and only single bonds. So if you only see single bonds, that's ane. Only single bonds here with 3 carbons is going to be prop for 3 and then ane for only single bonds. So we have propane. All right, what if we had 4 carbons? Well, that's going to be the prefix root word bute. And again, single bonds only gives us ane. And then pentane is going to be 5 carbons, only single bonds. So pent and then ane. What if we had a double bond? All right, so let's take a look at the structural formula really quick of this ethene molecule. Do all of these molecules satisfy the octet rule? Well, let's find out. Hydrogen, if you recall, only needed 2 valence electrons. And so this hydrogen has 1, 2, because each line represents 2. This hydrogen has 1, 2. 1, 2 for this hydrogen and 1, 2 for this hydrogen. They all look good. What about the carbons? So again, the lines represent 2 electrons. So this carbon is attached to 2, 4, 6, 8 electrons, and this carbon is attached to 2, 4, 6, 8. Okay, so both carbons satisfy the octet rule, but this looks kind of different than what we were seeing at before, because now we see a double bond. So if we see a double or a triple bond, these are going to be known as unsaturated hydrocarbons, meaning they are not saturated. We could put in extra hydrogens if we wanted to, but this specific molecule doesn't need them because it does follow the octet rule, so it's a stable molecule, and the root words still apply. So since we had 2 carbons, that's where we get the root word eth, eth, eth. Now the ending did change. Okay, so the ending did change. When there's a double bond, the suffix for the hydrocarbon is going to be ene, E-N-E. Not ane like we saw before, A-N-E. This is going to be E-N-E. All right, so here are some examples of the different hydrocarbons. 2 carbons gives us eth, but a double bond gives us ene, so ethene. 3 carbons gives us prop, double bond here gives us ene. It doesn't matter that there's a single bond here. As long as we have a double bond, that means we have a propene. Double bond here gives us ene, and 4 carbons gives us bute, so we see butene. Pentene is going to have 5 carbons with a double bond. Hexene is going to have 6 carbons with a double bond. Okay, so what about a triple bond? A triple bond is when you have 3 lines in between the carbons, just like this, and it's going to follow the same rules as the eth, prop, bute, pent, hex based off of the number of carbons, but now the ending is going to change one more time. The ending for these hydrocarbons is going to be ine, Y-N-E. So we have ethine, propine, butine, pentyne, and hexine. So basically we're combining these root words, these prefixes with the suffix, with 2 factors. 1 being the number of carbons, and 2, the type of bond that we see between the carbons. All right, so let's take a look at a few examples and see if we can practice this. We want to identify the following hydrocarbons as either saturated or unsaturated and provide a possible name for each. Okay, so for the one on the left here, we see only single bonds. I don't see any double or triple bonds, and we see 3 carbons. Well, the 3 carbon root word is prop, P-R-O-P, And we only see single bonds, so the ending is going to be ane. So this is going to be propane. Over here we see 4 carbons, so the prefix root word is going to be bute. And then we see a double bond, so this is going to have the ending ene. So this is butene. In this one, we see 4 again, so that's going to be bute, but now we have a triple bond, so that's going to be ine. So this is butine. In this one, we see 3 carbons, so that's prop, and a double bond, and that's going to be propene. In this one, we see 5 carbons, so that's pent, and only single bonds, so this is going to be pentane. All right, this is the final one. We have 3 carbons again, so that's prop, and we see a triple bond, so this is propine. So let's go ahead and try practice this one more time in practice problem number 7. Okay, so practice problem number 7 is actually really easy. All we're doing is taking a look at these 4 molecules and determining whether they are going to be saturated or unsaturated. All right, so go ahead, pause the video and try this on your own. It should only take you about a minute, but we're going to go ahead and jump into it right now. So the first one, we only see single bonds everywhere. So remember, single bonds means saturated. So this is going to be a saturated molecule. The next one, however, we do see a double bond in the middle there. So this is going to be unsaturated. The third molecule, we see single bonds primarily, but there is one triple bond right here. So once again, this is going to be unsaturated. And then finally, in the last molecule, we only see single bonds throughout this large molecule here. So this is going to be saturated. Okay, so one more thing to add to the saturated and unsaturated hydrocarbons. If the saturated hydrocarbons have simple covalent bonds that are going to be single bonds, they are known as what's called an alkane. So methane, ethane, propane, butane, pentane, so on and so forth. They all end in ane. And so they fall under the category of alkane. All of those are known as what's called an alkane. All right, but for unsaturated hydrocarbons, we have double or triple covalent bonds. And so if it has a double bond, whether it's ethene, butene, propene, hexene, whatever, they're all going to end in ene, E-N-E. So they fall under the category of alkene. Likewise, if they have a triple bond between them, the 2 carbons, they're going to be known as alkyne. So ethyne, propyne, butine, whatever. They end in ine, they're going to be known as an alkyne. All right, so let's take a look at practice problem number 8 just to review that one more time. Practice problem number 8 wants us to fill out this chart, to fill out the structural formula, tell if it's saturated or unsaturated, fill out the names, and tell us what type of hydrocarbon it is. Okay, so go ahead, pause the video, fill out this chart right now on your own, and we can check back to see if your answers are right. But I'm just going to go ahead and move on right into it. All right, so we have the type of hydrocarbon, which is an alkyne, so we know it's going to end in ine, so I'm just going to write down Y-N-E. And I know it has 2 carbons. So if you remember, 1 was meth. I'm just going to write this down on the side. 2 was eth. 3 was prop. 4 was bute. 5 was pent. And then 6 was hex. And that's all we're going to need for now. There are more, but we're not going to get into them. So if we had 2 carbons, the root word was eth, so we can write ethyne as our name for this compound right here. So if we had 2 carbons, I'm just going to go ahead and draw a carbon with a single bond and a carbon, but the ine represents that we have a triple bond in between the 2 carbons. So I'm going to go ahead and draw that triple bond. Okay. The next step after this is to just fill out the rest of the bonds that carbon needs with whatever hydrogens are necessary. Okay, so carbon right now has 2, 4, 6 valence electrons. Well, if we drew one more line, that would be 8, but we need to attach something to the end of this line, and you probably guessed is going to be a hydrogen. And the same thing with this carbon. This carbon has 2, 4, 6 valence electrons. It wants to have 8, so we're going to put in one there, H. There we go. Okay, really quick, we forgot that this is going to be saturated or unsaturated for this one. So the structural formula, we have single bonds only. You could probably guess that this is going to be saturated. This next one over here, we did have that triple bond, so we didn't have only single bonds. This is going to be unsaturated. Okay, so this next one, we have an alkane with 3 carbons. Well, 3 is going to be prop. So we have prop, and then it's going to be an alkane. So that ending, ane, carries over here. So propane is an alkane, and that means we're only going to have single bonds. So we have carbon, single bond, carbon, single bond, carbon, and then the rest are going to be just hydrogens. Here's a really easy tip for you, just to remember this. Carbon is always going to have 4 bonds connected to it. So carbon here, for this example, had 1, 2, 3, 4 bonds. This carbon had 1, 2, 3, 4 bonds. So carbon's always going to have 4 bonds. So in this case, you can just fill the rest of them with hydrogens. So this carbon now has 4 bonds. This carbon already has 2. 1, 2. So I'm just going to put one here, one here. And this carbon needs 3 more. And it's really easy to see this if you line up the structure really neatly like this with 90-degree angles, because each carbon can easily be distinguished. All the bonds can be distinguished using 90 degrees. All right, so now we wanted to determine, is this saturated or unsaturated? I only see single bonds, so this is going to be saturated. Okay, this next one, we want to fill out all of this information, and the only information that we are given is that we have the name. So we have ethane, and ethane is what type of hydrocarbon? Is it an alkane, alkene, or alkyne? Well, since the ending is ane, we know that it is an alkane. All right, I'm actually going to skip the formula for now. I'm going to do the structural formula first and then come back to the formula, because I feel like that's the easier way to go about it. So ethane has 2 carbons. That's what we've determined from right here. So ethane has 2 carbons, 1, 2, and then only single bonds. And so we're going to just draw out all 4 bonds for carbon and then put hydrogens at the end. Getting a little bit crowded here, that's okay. So carbon now has 4 bonds here, and carbon has 4 bonds here. So now we can go back and do the formula now, because it's easier. We can actually see all the hydrogens instead of having to guess how many hydrogens there are. So we knew that F means that we had 2 carbons, C2, and now we can count all of the hydrogens present. We had 1, 2, 3, 4, 5, 6 hydrogens. So 6 goes there. Last step, is it saturated or unsaturated? This is going to be saturated. All right. Next one, propene. Well, propene is a type of alkene. Just remember the endings are the same, right? So ene and ene, the endings are going to be the same. The same deal as before. What I would recommend is draw the structural formula. Maybe I'll do it in a different color this time so that we can actually distinguish the two. So propene, prop means that we have 3 carbons. So we have 1, 2, 3 carbons, and then an ene represents that we have a double bond. So I'm going to put a double bond right here between the first and second carbons. All right, and then we are going to fill the rest of the bonds for carbon. Remember, carbon wants to have 4 bonds total. So we're going to fill the rest with hydrogens. So there's 1 right there, 1 right there. So this carbon has 1, 2, 3, 4. This carbon has 1, 2, 3 bonds, so it only needs 1 more hydrogen, 1 right there. And this carbon has 1 bond, so it needs 3 more hydrogens. Okay. So the formula for this is now going to be C3, and how many hydrogens? 1, 2, 3, 4, 5, 6. H6. I can switch back to red here. So is this going to be saturated, unsaturated? We do have that double bond, so now this is going to be unsaturated. All right, for this next one, we are only given the structural formula. So what I would recommend is going from the structural formula, writing out the actual formula. We have 2 carbons and 4 hydrogens, so H4, C2H4. So let's go ahead and see if we can come up with a name for this. So 2 carbons, that tells us that the root word is going to be F. And we do see a double bond, so that means that the ending is going to be ene. So ethene, which is a type of alkene. And we know it's going to be unsaturated. All right, finally we have propyne. So propyne is a type of alkyne. And prop means that I have 3 carbons. 1, 2, 3 carbons. They are going to be linked with a triple bond because we have that ine. So here's a triple bond. And then we want to fill out the rest of the carbons with, or the carbon bonds with hydrogens. So this carbon, this first one has 3 bonds. It needs 1 more to have 4. There's hydrogen. This carbon already has 4 bonds. 1, 2, 3, and then 4. So that one's actually good. Doesn't need any more. This one has only 1 bond, so it needs 3 more hydrogens. All right, so now we can come back here and write out the formula C3, because we had 3 carbons. 1, 2, 3, 4 hydrogens, so H4. And this is also going to be unsaturated. All right, so that is practice problem number 8. All right, so the very last thing we're going to talk about with organic compounds and these hydrocarbons is something called functional groups. So believe it or not, carbon and hydrogen are not the only atoms in organic compounds. Functional groups are things that include other atoms attached to these hydrocarbon chains. So we're taking these specific groups and we are attaching them somewhere inside the chain. And all of these specific groups or these structures have a very important function inside of living things. So you can see here, like, for instance, the N with the 2 H's like this, the nitrogen and the 2 hydrogen. This is found in amino acids, proteins, so things that pertain to biology. So all of these things have very important functions in chemistry and especially the human body. All right, so these help determine things in biology such as carbohydrates, proteins, and DNA. All of these functional groups are groups that are later found in biology. So we don't really need to memorize any of these. We don't need to know what their functions are. What we want to be able to do is just to identify, based off of this chart, what they look like and where we could find them in an atom. That's all we are going to do. So let's go ahead and do that with practice problem number 9. Practice problem number 9 just wants us to identify the functional groups present in these hydrocarbons. So we still have the elements carbon and hydrogen being the most dominant elements here, but now we start to see other elements here like oxygen with a double bond, nitrogen, another oxygen here. So these are very specific groups, and what we want to be able to do is see if we can identify from this chart what one of these hydrocarbons functional groups are. So right now what I see is this functional group right here. And that's a group that is attached to the hydrocarbon itself. So I'm going to put the hydrocarbon right there. So that's separate. So this functional group, I want to see if I can identify as one of these. So go ahead and pause and see if you can figure out which one of these this is. If you haven't figured it out yet, it is indeed this carboxyl group right here. Actually, no, sorry, it's this aldehyde group. So there's a difference between this aldehyde and this carboxyl. And the difference between the aldehyde and carboxyl is that the C, even though they're both double bound to an oxygen, this is attached to a hydrogen here, whereas over here it's attached to an oxygen and a hydrogen. Right? And then we wanted to determine, is this part in the red portion saturated or unsaturated? So in the red portion, this is going to be saturated. And then the functional group that we see here, this was an aldehyde. All right, so the next one, we wanted to identify the functional group. So let's select a different color. And you can probably figure it out. It's basically anything that doesn't belong in that carbon-hydrogen chain. So that looks like it's kind of it doesn't belong, or it matches one of these. And this matches this one right here. This is called an amine group. And then this is going to be part of the hydrocarbon. Okay, so is this part in the red saturated or unsaturated? This is going to be saturated. So let me make sure I have the right color here. Saturated. And then the part in the green, that is going to be, once again, if I match it up to the functional group, that is the amine group. All right, and the very last one here, we'll do one more color. Let's say we'll do orange. That's this at the very end. So this OH, what does that look like? So even though this OH is together, it is a hydroxyl group where the O and the H is bound with a line. Sometimes we write it like this, sometimes we write it like this. They are both exactly the same. All right, so this OH is actually a hydroxyl group, and this is the rest of the hydrocarbon. So is the hydrocarbon part saturated or unsaturated? I only see single bonds, so it's indeed going to be saturated. And then the second portion here, we said that this functional group was the hydroxyl. The final thing I want to clarify here is that even though this whole molecule, so if I take away these squares, even though this whole molecule, let me move these really quick. This whole molecule does contain a double bond. That double bond is part of the functional group, not part of the hydrocarbon chain itself. So part of the functional group, even though we have a double bond, the hydrocarbon part itself is still saturated. So that's what we wanted to clarify. If we said unsaturated, that would have been incorrect. So there you have it. Those are the practice problems for Unit 3, Notes 2.